With this example, we are going to learn how to identify the end behavior of the polynomials. In order to be very effective in this section or in this topic, you need to memorize the chart on the top of the screen. So the functions, the polynomials, they can have even degrees and odd degrees, and the leading coefficients can be positive or negative. So depending on whether the function is even or odd and whether the leading coefficient is positive or negative, that's how we determine the end behavior. So let's look at some examples. F of x equals 5x squared minus 4x minus 3 minus 5x to the sixth power. You will start by determining the degree and the leading coefficient. When you determine the degree, please don't just look at the first thing. You need to look at all the terms. The degree is determined by the highest power on your x, which is 6 for us. Then the leading coefficient, that is the number in front of the x to the highest power, which is -5. Now, degree is even, and the leading coefficient is negative. So this is the graph that I want. And usually when we do the sketch of this, it's enough to just put both ends pointing down. Now, the second example has the polynomial in the factored form. We'll do the same thing, degree. So degree is a little bit harder to determine here, but all you need to do is just count all the x's. Here's one x. There's two of them in here because this parenthesis squared, so technically there's two parentheses that are identical. So 1, 2, 3, 4, 5. Degree is 5. Leading coefficient is, so then we have odd degree and negative leading coefficient. So odd and negative, that's this graph right here. And when you're sketching it, it's enough to put the left hand going up and the right hand going down.